presentation we are going to see about half adders, and before going to study about half adders we should be knowing the basics of binary addition, and you all know this. So 0 plus 0 gives you 0, 0 plus 1 gives you 1 in the sum, 1 plus 0 gives you 1 in the sum and there is no remainder, and 1 plus 1 gives you 1 0, right? In this 1 0, this 1 the 0 is the sum and the 1 is the carry. So here you can see 1 plus 1, right? 1 plus 1, the sum is 0 and the 1 is carried to the next digit, right? So this is how two ones are being added. So the logic circuit that performs this operation is called the half adder. So this half adder, it accepts two binary digits on its input and produces two binary digits on the output as sum and carry, right? So let's see how this thing works. So logic symbol of this half adder, logic symbol, so it goes like this. So the inputs are A and B, right? So we are assuming the inputs, and this is the sum, this is one of the outputs, and carry C out, this is one of the outputs. So these two are the outputs, right? So we are going to see the truth table of the half adder. Truth table. So what are all the inputs we have? A, B, and sum are carry out or the outputs. So can draw truth table for this, and it's very easy. Right, so 0 0 the initial state, so there is no sum, there is no carry, and 0 1, right? So the sum is 1, carry is 0, and 1 0, so 1 0 stands for 1 in the sum and nothing in the carry. The last one is 1 1, so 1 1 stands for no sum and there is a carry, right? Now if you watch this very closely, I'm adjust the screen now. So if we watch the truth table so close, we can find that the sum is equal to XOR of A and B, right? So sum gets a high value when there is if there is any one of the inputs are high, right? So we can assume that X can be A XOR B, sum can be A XOR B, right? So C out or carry out, so that can be A and B, right? So C out, this one gets high value when both of the inputs are high, right? So we can come to the conclusion that sum is equal to A XOR B and carry is equal to A and B. So we can use an AND gate and XOR gate to realize the half adder. So we can draw the logic circuit of this. Just a minute. Logic circuit of half adder, right? And it goes like this. So we have A and B are the inputs that can be given to XOR gate first. So this is A and B, which is equal to sum, and we can connect this B so it gets satisfied, right? A XOR B. Just a minute, I'll just change this. I'm sorry, A XOR B. Okay, so it is A XOR B, and we can draw a NAND gate. So you can tap an output from this, input from this, and you can connect this with this. So this is A and B, which is equal to carry out. So this is XOR, this is AND gate, right? So this is the logic circuit of half adder. In the next video we'll see about full adders. We'll follow the same rules of this. So we'll follow the logic symbol, the truth table, the equation, and the logic circuit.